Let's take a moment to review the notion of the absolute value of a number. What do we mean when we write the absolute value of x? The first way that we understand this is the absolute value of x means the distance between x and 0 on the number line. So, for example, here we have a number line, 0 at the center, or not quite at the center because my artwork isn't quite up to snuff. But if we take a look at, say, this number, this is 3.5. Well, the distance between 0 and 3.5 is just 1, 2, 3.5 units. So we say the absolute value of 3.5 is 3.5. Not very interesting so far. Let's look at another number. How about maybe -2 1/3? Well, the distance here is 1, 2, and 1/3 units. Right, distance, of course, can never be negative. So the absolute value of -2 1/3 is just 2 1/3. So just thinking about the picture more generally, to compute the absolute value of a number, if x is positive, the absolute value doesn't change anything. If x is 0, that's the point right at 0, of course, the absolute value of x is 0, which, of course, is still x when x is 0. If x is negative, right, so if x is less than 0, the absolute value of x is -x. Right, what does that mean? This doesn't mean force x to be a negative number. We mean the opposite of x. So, for example, the absolute value of -2 1/3, which we saw just up here, that's the opposite of -2 1/3. It's just 2 1/3. Where does the absolute value come in the order of operations? If we have an absolute value combined with other things, how does it work? In the order of operations, the absolute value bars are a grouping symbol, so they act like parentheses. When do we evaluate the absolute value? We actually take the absolute value when we would drop the parentheses. So here's an example. If we want to evaluate the negative of the absolute value of 3 minus 5 plus 7, the absolute value signs act as a grouping symbol and force us to do this computation first. 3 minus 5 is -2. So we'll have negative the absolute value of -2 plus 7. Right, so now we've done all of the arithmetic inside the absolute value. Now, we compute the absolute value. The absolute value of -2 is 2. And we copy the whole rest of the problem. And so now we can see we have -2 plus 7, which is 5. Just to practice evaluating the absolute value, and also make sure you have this order of operations stuff down because it's going to be very important very soon. I'm going to give you one of these to try. Evaluate -2 times the absolute value of 3 plus absolute value -5 minus 12. Pause the video and try this now. Okay, so what do I see? I see this inside an absolute value symbol, which tells me to do what's inside first. But what do I see inside but another absolute value? There isn't anything to do inside here. So now I'm going to evaluate this absolute value. I'll have negative 2 times the absolute value of 3 plus absolute value of negative 5 is 5 minus 12. So now I'm going to do this arithmetic. Negative 2 times the absolute value of 8 minus 12. The absolute value of 8 is just 8. So I'll have negative 2 times 8 minus 12. No more grouping symbols left now. So I think I should do multiplication and then subtraction. Negative 2 times 8 is negative 16. Negative 16 minus 12 will be negative 28.